In this video, we're going to be learning to complete the square. Our objectives are to rewrite functions in vertex form by completing the square, and we're also going to learn to solve by completing the square. So quick review, let's look at the standard form of a quadratic equation. We have the standard form here. Here's an example of a standard form. Standard form is ax squared plus bx plus c, where we have our x squared term. This is our quadratic term. This is our linear term, and we have our constant term. We've also talked about the vertex form of a quadratic equation, and here is our vertex form. And this form is important or helpful because by looking at this, you can tell that the vertex of this parabola is the point 6, negative 31. Okay? These two equations, both equations describe the same function. So what we're going to be doing is, here we have an example f of x of a quadratic equation that is in standard form, and we're going to take that quadratic equation and change it to vertex form, and this involves a process called completing the square. So first of all, what I'm going to do is take this and rewrite it as f of x is equal to x squared minus 12x. I'm going to leave a space because we're going to add something there, and then my plus 5. And then I'm going to add another space here. Notice here that the coefficient of my x squared is 1. So this is sort of a special case, and you're going to notice in the next example that I do that the coefficient of my quadratic term is not going to be 1. So here we have a 1x squared. So the first step here is to take this 12 and whatever this number is and divide by 2. And in this case we get 6. Now that 6 is going to go here and it's going to be squared. And then if we are adding, this is always a positive, if we're adding a 6 squared, which is 36, to this, then in order to keep this equation exactly the same, somewhere in the equation we're going to actually have to subtract that 36 or 6 squared, however you want to write it. Okay, so now what we've done here is create an equation that, let's just do a little side work. If I simplify, if I focus on this piece here, then what I have is x squared minus 12x plus 36. Okay, now the nice thing about this equation is that if you're looking for two numbers that multiply to give you 36 and add up to give you negative 12, you'll quickly realize that it's negative 6 times negative 6. So this can be factored as x minus 6 times x minus 6. Now also, I hope you realize that this 6, we can see the connection here. You have a 6. So leaving that as side work, what we're going to do to write this f of x now in vertex form is to write it as a quantity squared. It's going to be x, whatever this sign is, you take it. In this case, it's a minus, and then you take this value here. So x minus 6 squared, which you notice is what we got when we factored. And then we have our plus 5 minus 36, which if we simplify that, we end up with x minus 6 quantity squared minus 31. And so now you notice that our f of x is in vertex form. Our x squared minus 6, our x minus 6 quantity squared minus 31. So we could say that the vertex of that parabola would be 6, negative 31. Okay. So we're going to take that, and now I'm going to show you something else that's useful when you have this function here in vertex form. Once the square is complete, if I'm asking you to solve for this quadratic, find the solutions, then we set it equal to 0. And then to solve, what we can do is isolate the squared term. So I would get 31 is equal to, or maybe we want to put the 0 on the other side. Let's do x minus 6 quantity squared is equal to 31. And now I need to eliminate the square, so I'm going to take the square root of both sides, make this plus minus, and then I end up with x minus 6 is equal to plus or minus the square root 31. And then I'm going to add 6 to both sides and end up with 6 plus or minus the square root of 31. And these are the solutions. You can check this by using your graphing calculator, finding the x-intercepts, and if you plug this in and find out what your calculator gives you, that's a good way to check your answers. All right, now we're going to look at another example. This one's different. I still want you to complete the square and write it in vertex form. But in this case, you notice that we have a 5 here. So since we have a 5 there, that's going to make the process a little more complicated. We're going to start out with g of x is equal to, what I'm going to do is start out a little, sort of like we did the last one. We're going to keep the minus 6x, space, plus 8, and then another space. But in this case, what I need to do is I need to get rid of the 5, or factor out the 5 to get started. So I'm going to factor out that 5, and when I factor out, that leaves me with the x squared here minus 6 over 5 here. And you might think, well, why 6 over 5? Well, the answer is because 5 times 6 over 5 is equal to 6, which is what we have here. Okay, we want to be able to multiply this and get this 6 back. All right, we're going to leave a space, plus 8, and then another space here to prompt us to actually replace that with values. Okay, so from here, now it's much like the last. We take this number and we divide it by 2. Now, it so happens that this time it's a fraction, so rather than dividing by 2, it might make more sense to us to multiply this by a half. And when I do, I get 6 over 10, which reduces to 3/5. Okay, so 3/5 is my number. 3/5 is going to go here, but it's going to be squared, and that's a plus. And then over here, I'm going to subtract whatever I have there. But in this case, you notice that this 3/5 is not just 3/5 squared, but this 3/5 is actually being multiplied by that 5. So when I subtract, I actually have to subtract 5 times 3/5 squared. Okay? And so then once I'm here, I can rewrite g of x as 5 times the quantity of x. Remember, I take this sign, minus, and my fraction was 3/5 squared. And now I have plus 8 minus 5 times 3/5 squared. So if we square the 3/5, we can go ahead and do that, and that's going to give us 9 over 25. Okay, and we need to do a little work to simplify this. So let's do that. And then that will give me plus 31 over 5. Okay, and so now we have this in vertex form. And we could say that the vertex of this parabola would be 3/5. And you notice this sign is opposite this sign here. And 31 over 5. Okay. So now let's take this. And let's say the task was maybe not just to put it in vertex form, but maybe to solve for this quadratic. If I'm going to solve, then I first of all need to set it equal to 0. So 5 times the quantity of x minus 3/5 squared plus 31 over 5 is equal to 0. I'm going to subtract the 31 over 5 from both sides. And so from here now, what I need to do is divide by 5 or multiply by a fifth. These cancel. Okay, so I end up with this. And from here, I need to get rid of my this 2. And so what I do is I take the square root of both sides, since it's a quantity squared. Take the square root. This is going to be plus or minus. And so I end up with x minus 3/5 is equal to the positive and negative square root of 31 over 25. And from here I can just simplify. X is going to be equal to, I'm going to add 3/5 to both sides. And then simplify I know the square root of 25 is 5, so I can leave this as, and I know that since I have a negative 31, I might want to rewrite that as I square root 31, and we see that our solutions are actually imaginary. So I get this, okay? And we can also write that as 3 plus or minus I root 31 over 5. Okay, and so these are the solutions, which I notice are not real solutions. But I do have 2 non-real solutions for this quadratic. All right, now I have 2 equations here, 2 quadratics, and I would like you to solve both of these by completing the square and bring them into class tomorrow. A hint is that you might first want to set them equal to 0. Unlike the 2 equations that we worked with, you notice that you have this one is equal to -1 and this one is equal to this. So you might want to set one side of the equation equal to 0, move all of the terms to one side of the equation, and then go through completing the square and then solve by completing the square. And that's all I have for this video.